All right, today in Concept D, we're going to be focusing on functional groups and different families. Now, we've become familiar so far with hydrocarbons, branched hydrocarbons, and the substitution of halides or the haliocarbons. Now, there are other families of organic compounds if you check out Table R. These are molecules that contain a functional group, which is simply a group of atoms in a particular position that give the molecule very special properties. So today we're going to focus on alcohols and ethers. So to start off, we have an alcohol. This is a hydrocarbon with a substituted hydroxyl group, OH, as their functional group. So if you look on table R, you'll see the OH symbol here, and then this is how it would be bonded, R being a chain of carbons, and then this attached OH with the H directly to the oxygen. Now, alcohol, which is a covalently bonded molecule, are not bases, even though they look like they are a base with OH, but bases are ionic. So alcohols are molecular, polar, and water soluble. However, they are not a base. So you have to be incredibly careful, especially with methanol, to make sure that you're not labeling it as a base. So we're going to use the same naming system as our other hydrocarbons. However, the E at the end of the hydrocarbon is going to be replaced by OL. The same rules of naming the halogens, except we're now going to state the location of the hydroxyl group. So instead of stating the location of the halide, we're now going to state the location of that hydroxyl group. The position of the OH is always indicated by the lowest numbered carbon. Now, we will deal a little bit with when we have 2 or 3 hydroxyls on the group. So here we have what we call a diol, where we have 2 hydroxyl groups, and then a triol where we have 3. These won't come up very often, but I just want you to be aware of them. All right, so let's do 2 practice problems. Here we see that we have 4 carbons, so we have butane. However, the E is going to get replaced by the OL for our hydroxyl group, and we need to state the position of that hydroxyl group. So again, the butane part is coming from the 4 carbons. The OL is coming from the OH attached, and then I need to indicate the number of carbons, which is on the first carbon, so we have 1 butanol. All right, here we have 2 propanol. We're going to draw the 3 carbons based on the prop prefix. I have a hydroxyl group that I need to add onto my second carbon. So on my second carbon, I add my OH, and then I fill everything else in with hydrogens, and that's it. All right, the other thing that we need to know about alcohols is something called a primary, secondary, and tertiary. Primary alcohol is a hydroxyl group at the end of a chain. So just like in our previous example that we did a few minutes ago, the OH is at the end of a chain. So we say that's called a primary alcohol. A secondary alcohol is when it's in the middle of a chain. So here we can see that we have OH attached to the second carbon in our 3-carbon chain. So right in the middle, which is referred to as a secondary alcohol. A tertiary alcohol is when it's at an intersection. So here we have an intersection between carbons, and we have our hydroxyl group attached at that intersection of carbons. That's called a tertiary alcohol. All right, now we're going to move on to ethers. I really like naming these, but they can be a little bit tricky for students to name. These are made from dehydrating alcohols, so they're going to be a little similar. We're going to be having a general formula of ROR, meaning that we have 2 different carbon chains. So we're looking for an oxygen bridging between 2 hydrocarbon chains. So for naming these, we're going to name each of the branches or the alkyl groups off the oxygen, and we're going to alphabetize them if necessary, and then we'll simply add the name ether to the end of the name. Now, if you find that both branches are the same, you're going to use di in front of the branch name, and we never use numbers in naming ethers, just because we're specifically naming each side of the oxygen, so it's unnecessary. So here we have an ether, we have an oxygen with 2 different hydrocarbons attached to it. We're going to name each of them, so we have first off ether, then I have an ethyl group, so we have 2 carbons, and then I have another ethyl group of 2 carbons. However, I can also, because they are the same, write this as diethyl ether. Here we have methyl ethyl ether. So the ether part is giving us the oxygen in the center. Methyl is 1 carbon, so I'm going to place that on one side of it, and ethyl is 2 carbons, so I place that on the other side of it. So I have methyl ethyl ether. All right, that's it for alcohols and ethers. Tomorrow we'll be moving on to aldehydes and ketones.